Hello students, today I am NEET 2016, the next 5 questions from 6 to 10. So now question number 6 to 10. Now question number 6. Two identical charged spheres. Two identical charged spheres suspended from a cone suspended from a cone point by two massless by two massless strings of length L. Strings of length L are initially at distance D. Are initially at distance D, where D is very less than L. Apart because of their repulsion. The charges begin to leak. The charges begin to leak from both spheres at constant rate. From both spheres at constant rate. As a result, spheres approach. As a result, the spheres approach each other with a velocity V. The V varies. The V varies as function of distance x. Of distance x between spheres as Now option is number 1, v raised to power v proportional x raised to power minus 1. Second, v proportional x raised to power 1 by 2. And third, v proportional to x. And fourth, v proportional to x raised to power 1. This is the given here. Now the solution to this question. What is given? That we have two identical spheres which have the same charge and they are apart from each other with a distance d because of the repulsion force. And when the charge leaks from both of the charge spheres, they approach each other with a velocity v. And we have to find that what is the relationship between the velocity and the distance between the charges. So when the charge leaks from the spheres, it means that this is the current. So we have to find the relationship between the charge and the distance between the spheres. So what is given here? Initially, this is the single point, this is the sphere, this is the sphere, this is point O, this is sphere A, this is sphere B, and this is the length of this thread, and the distance between them, this is now given d. This is given. This is the initial stage, and they repel each other with a force F. They are positively charged, positive. And now what happens? That the charge from these spheres start to leak at a constant rate. So, because of leak, these points now they come close to each other with a velocity v, and the distance between them is, this is now x, this is A, this is B, this is now O, this is now thread, and the force between them again is the F. So now what? We have to find the distance, and that this angle is taken to be theta, or we can say it to be not 2 theta. This kind of question I have told you earlier also. If you remember that this is the thread, this is the tension T, and this angle is your suppose 2 theta, then we can divide this tension into the two parts. This is now your T cos theta, and this the towards this one it will be T sin theta. Similar in this one, this is angle 2 theta, so this half of this angle is theta. So this angle is theta now. So now you can see that there is a weight of these spheres, that is now mg. So now you can see that the three forces are acting simultaneously. One is the tension in the string, second the weight of the sphere, third the electrostatic force. So what we have, there is T sin theta is equal to F. So this T sin theta equal to what we have taken, kq square upon x square. The distance between them, this spheres, is now this x. So we have to find this to be x, and then this t cos theta, this is equal to n. Now these are the two equations. We have to eliminate t, so just we divide the equation number 1 by equation 2. Dividing 1 by 2. What we have? T will cancel, this is now tan theta. Tan theta is equal to what? We have this kq square upon x square into n. Now then this, you can see that since the angle is very small, so this tan theta, that we have to take it, if you just drop a perpendicular from this, then this angle is to be theta and this angle is also theta. So this tan theta we can take approximately equal to sin theta. Sin theta, this is now your this distance, or we can say that this distance will be here. This whole of the distance is x, so this distance is xy. So now this angle is theta and this angle is also theta. So you can see that from here that this sin theta equal to perpendicular upon hypotenuse. So this perpendicular is x upon 2 into, now this is L. So this is kq square upon x square mg. So now this, you see that this is now x cube. X cube is equal to 2l q square k upon mg. So what we have relation? That this x cube equal to a constant k dash into k square, where k dash is equal to 2l k upon ng. And you can readily, you can see it directly from this one, that this charge q or this q equal to proportional to x raised to the power 3 by 2. So what we have, just to differentiate to this one, then dq upon dt. This is the rate of leakage of the charge, and this is equal to a constant, or we can write it to be x is q square equal to k dash into x cube. So this will be equal to your mg is equal, this is the reverse, mg upon 2lk. So this is equal to the constant this k dash into, this is now your 3 by 2 x raised to power half into dx upon dt. This dq upon dt, this is constant, or we can say that this dq upon dt equal to 3 by 2 k dash into x raised to power half into v. Since dq upon dt is equal to constant, so v 1 by 2 into v, this is equal to constant. because all these are quantities are constant, so we have this V is proportional x raised to power half. It means that the speed between these spheres will be proportional to x raised to power minus half. So our option is fourth. So our right answer is fourth one. So just what you have to find? Just you find this equation t sin theta, t cos theta, and then this one, and then this, and this is find the tan theta. Theta being very small, so you take it to be tan theta, sin theta. So this is equal to, this distance is x by 2 into L. So this will be, you will find here, and then find the relationship, and then differentiate, and you will find that V will depend upon x as a power minus half. So our right choice is to this one is fourth one. This is question number 6. Now question number 7. A capacitor of 2 microfarad is charged as shown in diagram. Is charged as shown in diagram when the switch is turned to position 2. When switch is turned to position 2, the percentage of its stored energy dissipated, the percentage of its energy dissipated is. So now we have the options. First I will make the diagram. This is is 1, this is not 2, and here we have a capacitor. Here also we have a capacitor, like this is now 2 microfarad, and this is of 8 microfarad. So now you have to find the your options are 80%, second is your 0%, third is your 20%, and fourth is 75%. These are the options. Here we are given the battery of voltage V. Now in this question, this capacitor of 2 microfarad is being charged with this battery V. When this is connected, the switch is connected to position B. then we have to find that what energy is being lost by connecting this to the point 2. So you can see that this is at the voltage B and this is not connected by the battery. So this its voltage is 0. So what we have? The energy lost. Dissipated, delta U equal to, as our formula we have C1 C2 upon C1 plus C2 into B1 minus B2 whole square. This is given to C1, this is given to C2, and V1 is equal to now V and V2 is equal to 0 for this one. So this is delta U equal to 1 by 2. This is now your 2 microfarad into 8 microfarad upon 2 microfarad plus 8 microfarad into V1 is now V and this is your 0. This is whole square. So this is 2 and 2 will cancel. So this is your, and this your 1 microfarad into 8 microfarad upon, this is now your 10 microfarad into V square. Microfarad will cancel. This is now your 5, this is now your 4. So this is 4 upon 5. So delta U equal to, this is 4 microfarad into V square upon 5. You have to find the percentage. This is the energy dissipated, but not the percentage. So to find its percentage, what we have, that the initial energy U1, this is equal to half C1 B1 square, and this its energy is 0 plus half C2 B2 square. So this is now half C1 is 2 microfarad and this is now your V square into plus 1 by 2, C2 is 8 microfarad into V2 equal to 0. So this 2 and 2 will cancel and this will give you this microfarad into V square. This is equal to U1. So now you find the ratio of these two. Then what do you find? That if we take delta U upon U1, that will be equal to 4 by 5. Therefore, delta U upon U1 equal to, this will be your 4 upon 5. Then you have to find the percentage. Just you multiply by 0. This is now 0.8 or 80%. It means that 80% of energy will be lost. So this is the right answer is first one. I have told you this is such kind of question earlier also, but there these two capacitors were of the same capacitance. So either you find like this one or you can find by another way also. First you find the initial energy just like this and then final energy. just by having this common potential to this one, both of these two V, and then find the difference, that will give you delta U, and then divide by initial energy, so that will give you delta U upon U1, and then find the percentage. So our right answer is first. This is the percentage loss of energy dissipated. Percentage of its stored energy dissipated. Now question number 8. A particle moves so that its position vector, its position vector is given by R equal to cos omega t into x cap plus sin omega t into y cap, where omega is a constant Which of the following is true? Question is, which of the following is true? Now this first option is velocity is perpendicular to R. Velocity is perpendicular to R, and the acceleration is directed away from origin, and acceleration is directed away from origin. Second, velocity and acceleration velocity and acceleration. Acceleration. Both are perpendicular to R. Both are perpendicular to R. And third option, velocity and acceleration are not perpendicular to R. And now fourth is here. That velocity is perpendicular to r. Velocity is perpendicular to r, and acceleration is directed directed towards origin. These are the options. Though this is the question of simple harmonic motion, and this is also taught in the classroom that the velocity is always perpendicular to the displacement, and the acceleration is always directed towards the origin or towards the mean position. So you can have the direct choice, you can select the direct right choice from these given choices. So what we have that either you find the first velocity and then acceleration, and then find the dot product of velocity and acceleration with this r, then you can find what is there, or you can have direct by applying the theoretical concept. This r cap, this r vector r equal to cos omega t into x cap plus sin omega t into y cap. So now velocity v equal to dr upon dt. So this will be your omega, cos, this will be your sine with a minus sine omega t into x cap plus omega cos omega t into y cap. Then find the acceleration. This a is equal to dv upon dt. This you are given dv, so this you will find this minus omega square cos omega t into x cap. This is now minus omega square sine square omega t into y cap. So what we have, this you take minus omega square constant, then this is cos omega t into x cap plus sine omega t into y cap. You can see that this is now r, this is given here. So this is minus omega square into r. So this is the acceleration a. So now if you want to find out this the standard formula of the SHM, so this shows that this acceleration is always directed towards the center. This minus sign indicates that this is always towards the center. And now if we find this the dot product, so if the dot product of v and r comes out to be 0, then angle between them will be 90 degree. So you can have this like this. V dot R. V is given to you, this omega you can take constant from these two. So this is omega into sine omega t with a minus 1 and x cap plus cos omega t into y cap dot. Now then this R, this is your cos omega t into x cap plus sine omega t into y cap. Okay, so now justify that I and I, j and j, k and k, they are equal to 1, remaining are 0. So you just multiply to this one, then we will have this this omega. This is your sine omega t, or this is cos omega t, and then this plus cos omega t into sine omega t. So this will cancel, both the terms will cancel. So this is equal to 0. So V dot R equal to 0. So we can have this VR cos theta equal to 0, or this gives you that cos theta equal to 0, or this gives that theta equal to pi by 2. So velocity and this position vector are mutually perpendicular, but this acceleration directed towards the center. So our right choice to this one is that velocity is perpendicular to R and acceleration is directed towards the origin. So fourth option is correct. Here we have the answer fourth. This is the question number 8. And now question number 9. Question number 9 is from a disk of radius r, from a disk of radius r and mass m, a circular hole of diameter r, whose rim passes through the center is cut what is the moment of inertia? Question is, what is the moment of inertia of the remaining part disk about its perpendicular axis. About its perpendicular axis. Passing through center. Passing through center. Now the options are: first is 9 mr square upon 32. Second is 15 mr square upon 32. And third is 13 mr square upon 32. And fourth is your 11 mr square upon 32. These are the options. So how to find the solution? You are given a circular disc of radius r and mass m, from which a hole of diameter r is cut in such a way that its rim passes through the center of the disc, and then you have to find the moment of inertia of the remaining disc. So now if I draw the diagram, then you can see that this is the disc, this is its center, this is a hole, this is a circular hole, this is center OS, this radius is r, this is r, this radius is r by 2, this radius is r by 2. Because so much is r, then this will be r by 2. This is the center of this disc, this is the hole, this is hole, this is disc. And now if we find the axis which is perpendicular to the plane and passing through the center, then you can see that this is like this one. This is the axis AB. Another axis is from this OS, which is a circular hole. Then this diameter is, its axis is like this. These are the two axes. So you are given that the mass of this disc is m. Mass of disc equal to m. Now if we have this diameter to be r, then we can find the 4 holes in this disc. It means that this is the 4th part of this disc. So the mass of this removed circular part will be m by 4. This you can also find by taking the mass per unit area. Then you can calculate that this also will come out to be m by 4. Mass of removed disk is equal to m by 4. So what we have, that this radius of the removed disk, radius of removed disk, this is equal to r by 2. So now you can see that these two axes are parallel to each other. Then to find the moment of inertia of this remaining disk, we have to find the moment of inertia about this axis AB that passes through the center and perpendicular to the plane of the disk. So now distance between these two, this is now r by 2. This is so much. Mi of removed disk, this is equal to, we will apply the formula I equal to Ig plus Md square. Ig plus Md square. Here this M equal to m by 4 and d equal to r by 2, and this Ig of this circular disk, and that we know that this Ig of circular disk is equal to 1 by 2 mr square. So this Ig will come out to be 1 by 2 m, this is now m by 4, this is r by 2 whole square. Now we put all these values here, then this is equal to your, this you can see this 4 and 4 16 and this 32. So this is mr square upon 32 plus m into d is equal to r by 2 whole square. So this is equal to this is now 4, so 819. So 9 by 32 mr square. This so much will come out. This is the moment of inertia of the removed disk or this hole. So now moment of inertia of the remaining disk is how much? So mi of remaining disk is equal to, the moment of inertia of this whole of the disk is 1 by 2 mr square, and then subtract to this one minus 9 upon 32 mr square. So now if you can see that this is your 13 mr square, you just take common. This is your 1 by 2 minus 9 upon 32. So this is your mr square. 32 you take LCM. This is now your 16 minus 9. Four and 4 16 into 32. This is your m r square upon 4. M r square upon 4. 4 8 32 1 4. So this is 8 upon 9. 9 upon 32 m r square. So this is your, not so much. this is m by 4. We have not taken to be this m by 4. So this will come out to be total is 3 upon 32 mi square. This is 3 upon 32 mi square. So this is now 3. This is now 3. So this is your 13 upon 32 mi square. This is the moment of inertia of the remaining disk. So now you can see that the right answer to this one is third, 13 mi square upon 32. So our answer is third. Now I am taking another question which is very parallel to this question. Now this was the question number 9, and then I take the question number 10. Question number 10 is the ratio of escape velocity of escape velocity at Earth VA to the escape velocity VP at planet VP whose radius and mean density are twice as that of Earth is now the option. This is the 1:√2, second 1:2, third 1:2√2, fourth 1:4. This is the question number 10. The solution to this one: you are given the escape velocity. So we know that the escape velocity VE at the Earth, this is the square root of 2gme upon RE. ME the mass of Earth, RE the radius of the Earth. So this we will represent like this is square root of 2g. Mass equal to radius into the density into volume. Density, this is now rho, volume 4/3 pi RE cube upon RE, where rho equal to density. So what we find that this VE equal to 8g pi upon 3 g pi, and this is r rho and re square. This is on the earth. Now at the planet, Vp equal to square root of 3g pi upon 3 will 8, this will remain as such, 8 g pi upon 3. Now this rate rho is 2 times, this is not 2 rho, re, this is not 2 times, 2 re whole square. So what you find? This is equal to square root 8 g pi upon 3 into, this is also 8, so rho re square into 8. Just to find the ratio, ve upon v. All quantities will cancel, only remaining 8. So this is 1 by square root of 8. So this is 1 upon 2 root 2. This is 1 ratio 2 root 2. So this is the direct application of the escape velocity formula. So our right answer is the third answer. Third. So these are the 5 questions from 6 to 10. I have explained this in with all these diagrams, and I think that you will understand it. Thank you very much.